Hello guys, today I'm going to be talking to you about my building quadrilaterals assignment. So what I'm supposed to do here is build as few quadrilaterals as possible to satisfy each constraint at least once. And I also needed to include diagrams which shows my visual thinking, and of course I did. And here are the constraints. Constraint A has at least one pair of parallel sides. B has a right angle. C is a trapezoid. D has opposite sides of equal measure. E has at least one obtuse angle. F can be dissected into two isosceles triangles. G has all sides of equal length. H has a reflex angle. I is a parallelogram, and J has adjacent angles of equal measure. And the prompt for this thing is, and we had to do it in a prompt. So the prompt is, you need to use each of the following characteristics to build as few special quadrilaterals as possible so that each property is used at least once. How many special quadrilaterals do you need to do this? Be sure to describe how and why you built the quadrilateral the way you did, and be sure to identify which quadrilaterals satisfy which constraints. So my hypothesis for this question is that it will take 4 quadrilaterals, and these 4 quadrilaterals were drawn below. And note, this answer and the correct answer are going to be written in the same format. I'm going to explain. And also, as you can see here, the constraint, aka properties, are diagrammed on the quadrilaterals and color coordinated. So please pay attention. And also remember that these shapes were my hypothesis. So I made this quadrilateral a parallelogram, as you can see here. And the constraints that go with this quadrilateral are I is a parallelogram. E has at least one obtuse angle, and the obtuse angle is right here in red. A has at least one pair of parallel sides, and it has 2. Yeah. It has 2 pairs of parallel sides, and they are written in green. And D has opposite sides of equal measure. And as you can see, I wrote that on my parallelogram in blue. Right over here and here, here and here. That means these sides are congruent and these sides are congruent. I created my first quadrilateral as a parallelogram because already one shape needed to be a parallelogram. And I actually thought that a parallelogram needs to actually look like a squashed rectangle, and a square does not count as a rectangle. And as I drew the parallelogram, I also found the other properties, or the constraints, after drawing it basically. And those other properties are properties E, A, and D. And now moving on to the second quadrilateral. I chose to draw my second quadrilateral as a square, as you can see here. And the properties that are constraints that go with the shape are A has at least one pair of parallel sides, and I did show it right here, 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 and here. So basically I showed that these two sides and these two sides are parallel, or you can just think of them as the opposite sides. The next constraint is B has a right angle, which basically means that it has at least one right angle, and in a square there are 4 right angles. And there's another constraint. D has opposite sides of equal measure, and G has all sides of equal length. And as you can see, I've done it in blue, so that means all 4 sides are congruent. And since all 4 sides are congruent, that means opposite sides have to be congruent as well. And F can be dissected into 2 isosceles triangles. I marked it in green over here. And how can they be even dissected into 2 isosceles triangles? So here's my explanation. I created the second quadrilateral as a square because this is the only one that can be cut into 2 isosceles triangles. And how can it be done? That's the question. All 4 sides are congruent in the square and the isosceles triangles. The 2 shorter sides are also the sides of the square, and of course that automatically says that they're isosceles. And the diagonal is the hypotenuse of the 2 triangles. The other properties are the properties of the square, and I discovered them as I drew the square. And those properties are A, B, D, and G. And then number 3, I chose to draw it as a trapezoid, and the constraints that go with this quadrilateral are C is a trapezoid, so I drew it in purple. A has at least 1 pair of parallel sides, and I marked it in a magenta color here, like on opposite sides. And then E has at least 1 obtuse angle. I marked it in a nice pretty aqua blue right here. And J has adjacent angles of equal measure, and that means that these 2 angles are congruent to each other, and these 2 angles are congruent to each other. And why did I create the third quadrilateral as a trapezoid? I created it as a trapezoid because a trapezoid is a required constraint, as it was said in the first page. And since the square already had right angles, I decided that this quadrilateral would be an isotrapezoid. I just like isotrapezoids better. And the constraints A and E automatically show up on the quadrilateral since they are the properties of an isotrapezoid. And that's about it. Actually, no. Constraint J is also a property of a isotrapezoid, and of course I created the third quadrilateral as an isotrapezoid. Finally, fourth quadrilateral. I drew this as a concave polygon, as you see here, and the constraints that go with this polygon are that it has a reflex angle. I chose to construct the fourth quadrilateral this way because no other quadrilateral would have a reflex angle, and the only quadrilateral that has it is a concave quadrilateral. And was my hypothesis correct? We're going to find out. My hypothesis was incorrect. And the correct answers are on the next page, and they are in the same format as the previous page, so do not get confused. And the correct answer to this question is 2 quadrilaterals. And the first quadrilateral is a square. And the constraints that go with this quadrilateral are A has at least 1 pair of parallel sides, And I showed that in blue right there and there, right there and there. That means opposite sides are parallel. And I is a parallelogram. Well, it's implied, but I'll explain to you why it is a parallelogram later. And D has opposite sides of equal measures, and G has all sides of equal length. If constraint G applies to this polygon, then automatically constraint D will have to apply. And then B has a right angle, and it has, of course, 4 right angles. And as you can see here, I marked it in orange. And then I had J has adjacent angles of equal measure. It's because all angles are 90 degrees. And it also can be dissected into 2 isosceles triangles. And it is also a trapezoid. I chose to draw my first shape as a square because it's the only shape that can be dissected into 2 isosceles triangles. Why? Because 2 of the sides of the isosceles triangles are sides from the square. And a property of a square is that all 4 sides are congruent. And interestingly, that is a constraint. That implies that 2 of the sides of the triangles will be congruent, and that automatically means that it is an isosceles triangle. Since this shape has 4 congruent sides, opposite sides of the square are congruent. And also, since the shape is a square, it has 4 right angles. That implies that constraint B, listed above, applies to this shape. And since all 4 angles in this shape are congruent, the adjacent angles must be congruent, aka having equal measure. And the 4 angles are congruent since they're all right angles, and all right angles equal 90 degrees. And the constraint C can also go well with this shape because a trapezoid has at least 1 pair of parallel lines, even though it doesn't look like a trapezoid. A square can also be considered a parallelogram because it has 2 pairs of parallel sides. I think this shape covered most